So hello everyone. So I'm going to be talking about what's wrong with Git. They've been talking about a lot about like big repos and all this other stuff. I'm actually going to be focusing on the usability aspects of Git. So we all know what Git is. It's a free and open source distributed version control system that actually, according to its website, is easy to learn, is performant, and has features such as cheap local branching, convenient staging areas, and support for multiple workflows. Now, none of these claims have been disputed but one, that is easy to learn. And I'm going to show you some results from surveys conducted by other researchers and by the Git community that dispute this claim that Git is easy to learn. For example, the authors of this paper conducted a study in which they interviewed engineers at Google and Autodesk to study the effect of hidden dependencies on version control. And the term hidden dependency comes from the cognitive dimensions framework. Maybe that rings a bell to you, but if it doesn't, then it doesn't matter. Because what I like to focus on is on some of the patterns in the usage of Git that they have observed in their study. Here are two of them, which I found quite interesting. So first, they found that users had low confidence in Git, where, for example, even one of the most experienced Git users requested that someone else perform an operation on the repo because he or she was scared about the consequences of running the Git command. Now, if you're a Git pro, you'd probably find this baffling, right? How could someone be uncertain of the consequences of running a Git command when it is, after all, very clear what commands do from the documentation, right? I mean, take the documentation for Git rebase, for example, right? Forward port, local commits to the updated upstream head. That's it, right? What else is there to say? Here's another Git command that is very clear what can be used for. Git wave stash, wave all stage stashes next to various cherry pick non-applied applied trees. Or this one, Git distinguish tree, distinguish a few non-clean remote trees inside various red-listed upstreams. And this is my favorite. And this one is very useful. Maybe if you're working with some modules, you've used it before. Git control stash, control some non-bundled state stashes over any shown submodules. All right. So maybe by now you might have realized that I've been tricking you and that the last three commands were fake. And maybe if you're a Git expert, then rebase makes sense to you. But to most users, especially novices, it probably makes as much sense as Git control stash. Now, going back to the observations from that study, the other thing they found is that repair operations are expensive, to the point that several members of the team reported having to perform repeated local repairs by recloning the entire repo. And this situation is beautifully captured by this XKCD comic. You know, there's this saying that there's always some truth in a joke. If you can see, play almost maps 1-to-1. So there's also evidence that Git is not easy to learn in surveys conducted by the Git community. For example, there was a question in the 2012 Git user survey that asked, what do you hate about Git? And if you look through the responses, you'll find things such as the fact that it's too complex for many users, that it requires a steep learning curve for newbies, dark corners, and so on. Here's another question. This one is from the 2011 survey. And the question is, which of the following features would you like to see implemented in Git? And the third most voted option is this adding a just -n flag for each command, which would describe what would happen if you were to execute that command. Right? And this option might help users such as this one from the study that was scared of running a Git command. But adding a flag like this, it seems kind of like merely treating a symptom. And I think that what we need to do is to try to get to the root cause of why many people find Git scary and hard to learn and use. So now, as being researchers, we really wanted to get to the bottom of this and put forward a hypothesis for what's wrong with Git, and hopefully extract larger lessons about software design in the process. So I'm going to show you three examples of problems encountered by Git users. And these are related to switching branches, the detached head state, and untracking or ignoring a tracked file in Git. All right, so let's talk about branching in Git. So branching is a difficult thing to understand in Git. But fortunately for us, a Git user came up with this way of thinking about Git that might help us understand branches. So it apparently all makes sense if you think of branches as n-dimensional membranes mapping the spatial loci of successive commits onto the projected manifold of each clone repo. Okay, so maybe this explanation of branches makes sense to some of you. But for the rest, I'm going to keep a quick overview of how branching works in Git. So a branch is pointed to a commit. For example, in this repo, we have master branch that points to commit 2. Great. You can now create a new branch, develop, and switch to it. And if you make a new commit, then this new commit belongs to branch develop only. Awesome. OK. Now, here's a problem with switching branches, as exemplified by this Stack Overflow question. And basically, what's going on here is that the user wants to switch, but uncommitted changes in the working directory and/or staging area prevent the user from doing so. The problem here is that since there's only one working directory and staging area, any uncommitted changes that conflict with what's on the destination branch will prevent the switch. So what could you do if you find yourself in this situation? Well, you could create a new commit with unfinished work, but this commit would not represent a logical group of changes, since presumably you're in the middle of doing some work, right? So if you actually care about having a tidy commit history, and you probably should, you have to amend this commit afterwards. Another alternative is to stash your changes. And this is probably what most of you may be doing in this situation. And it works well in most cases. But if, for example, you're shuffling between multiple tasks, it gets hard to remember and apply the correct stash that corresponds to the branch you're switching to. You can start naming them and so on, but it gets quite hairy. And even so, if you're in the middle of a merge, then stashing doesn't work. Now let's move on to the second problem that is related to the detached head state. So as probably many of you know, Git has a head, which is a reference that keeps track of the current commit. And it usually does so by pointing to a commit through a branch. Right? So for example, in this case, we have a head that points to master, that points to commit 2. But what's interesting is that in Git, you can make a head point to a commit directly, right? Which puts you in a detached head state. And now, if you make a commit in this state, this new commit doesn't belong to any branch at all. It's kind of like flying there in a parallel universe that is unreachable from any branch. And this confuses these novices that usually get into a detached head state accidentally. So for example, in this question, the author tried something which didn't work, and is now in a detached head state, and has no idea how to get out of it. Now, the detached head state not only confuses Git users, but also military officials which are trained in Git. Maybe you've seen this one before. All right, so the last problem I want to tell you about is related to untracking or ignoring a tracked file in Git. And it's exemplified by this Stack Overflow question. So how do you stop tracking a tracked file in Git? So that is what happens if you have a file that is committed in the repo, which you now want to ignore untracked. Well, so as the author of this question did, you can try to modify the git ignore file, but that doesn't work. And the solution to this problem, at least one of the potential solutions to this problem, is to mark the file as assumed and change. Actually, the current advice is to use a skip worktree flag. But anyway, still most people use assume and change instead. But that means you need to learn a whole other set of commands to deal with these kind of files. And many wonder how to list them or how to undo the marking. But you know, in general, undoing things in Git is easy. Right? And worst case scenario, you can always use Google to figure out what to do. Okay, so to determine how closely these problems I talked about and some others that we identified in the study we conducted, match the problems that users experience in practice, we performed a manual analysis of Stack Overflow posts. So we started by finding all questions tagged with the keyword Git. We then filter out all questions except those with more than 30 upvotes. And we then examined by hand all the remaining questions to determine whether or not the issue being asked about was related to one of the problems we identified. And for example, for switching branches, we found 3 questions with over 500,000 views. For Detached head, we found 7 questions with over 1.1 million views. And for untracking file, we found 15 questions with over 1.5 million views. We did this in a few months ago, so numbers are probably higher now. But you hopefully get an idea of how real these problems appear to be. So let's try to understand what's going on here. First, let me point out that I've actually never talked about the UI. I've never talked I never said anything about a flag being inconsistent or a command having a weird name or so. Although all of the problems I mentioned are related to these concepts such as branch, head, and so on, and how they interact with each other. So to try to understand what's wrong with Git, we applied a new theory of design that focuses on the purposes and concepts underlying software. And I'll give you a quick overview of the theory that we apply in this work. So a key aspect of the theory is the notion of a concept, which is something you need to understand to use it as an application, as something a developer needs to understand to work effectively with its code. So for example, for Twitter, the notion of a user and tweet would be concepts, while a class, assuming that they use, say, some object-oriented language or so, would not be a concept since the user of Twitter doesn't need to be concerned with that at all. On the other hand, the notion of a class would be a concept in Python, because as a user of Python, you need to understand what a class is in order to use the language. Same for module. But other notions, such as opcode, their implementation details will not be concepts. A concept has a motivating purpose, which is the reason why it's there in the first place. So for example, for the trash can in your house, the purpose is to serve as a staging area for trash. Right? You don't want to have to, every time you need to throw something away, go out of your house and put it in the bins outside. So you collect trash in the trash can, and then you take it out when it fills up. On the other hand, the purpose of the trash can in your operating system is to allow deletions to be undone, so that if you delete a file by mistake, you can recover it easily. An operational misfit is a scenario where the concept fails to fulfill its motivating purpose. So for example, for the trash can in macOS, a misfit would be that if you delete a file by mistake and you cannot remember its name, then there is no easy way to find the file. You have to scroll through all the files to find it. So it may not be possible to restore it. Now, in some cases, a misfit might be remedied by a small change in the design of the concept. And actually, in recent versions of macOS, this doesn't happen anymore. They fixed the misfit by adding the deletion data, sort of metadata. But misfits might also signal a deeper issue that is not easily resolved. And ideally, you'd like to identify these misfits as early as possible, and which lead us to this criteria for concept design. And this represents situations you would like to avoid. And an arrow here denotes, relates a concept with its motivating purpose. And the dash arrow simply denotes that there's an interference between them. OK, so now let's apply the theory to Git to attempt to provide an explanation of what's going wrong with Git in these situations. So the first step is to establish a set of key purposes for version control. And the goal here is to establish a kind of benchmark for a generic version control system against which Git can be evaluated. And hopefully this kind of makes sense to you. It's probably the reasons why you use a version control system. OK, so let's go back to our misfits and use the theory to explain what's going on. The misfit switching branches is caused by the violation of the coupling criterion between the working directory, staging area, and branch. because the working directory and staging area are interfering with the fulfillment of the motivating purpose of the concept of a branch, that is to support parallel development. You want to switch to some other parallel task, and you cannot. And so to work around this problem, many people, as I said, use stashing. So let's talk about stashing and apply the criteria to the concept of the stash. So what is the motivating purpose of stashing? So if you're the creator of the software, then you simply know. But in this case, since we are evaluating an application that was created by others, we need to rely on sources such as the official documentation and popular Git references like the Git book. So here's a description of stashing. And if we look at the Git stash documentation, you see that it quickly points out the saving of the changes and cleaning of the working directory and staging area. So use Git stash when you want to record the current state, but want to go back to a clean working directory. And the same thing happens in the Git book. Stashing takes the dirty state of your working directory and saves it on a stack of unfinished changes. OK, so we now have the motivating purpose for stash, that is to clean up the working directory and save uncommitted changes. So now the question is, this purpose is a sub-purpose of which of the high-level purposes for version control? You could argue that it is a sub-purpose of making a set of changes persistent. But while it is true that you are indeed saving changes, the ones in your working directory and staging area that are being stashed, this doesn't account for the cleaning of the uncommitted changes, which, as we've seen, is a crucial aspect of stashing. You could argue that it should be a sub-purpose of supporting parallel development, because stashing is letting you switch and later kind of synchronize between two implicit lines of development, one that represents, one that essentially has the uncommitted changes you want to save, and the other one that consists of any new changes that to be pulled or developed. But these are hardly genuine lines of development and are instead more like ad hoc states of branches. Maybe you'd say that this clean up the working directory while saving the uncommitted changes should be right up there as a high-level purpose for version control. But this seems wrong, too. When you're selling version control to someone, you're not going to say that you should use a version control system because you have stashing that lets you clean up your working directory while save your uncommitted changes, right? Most people's reaction is going to be like, why would I even want that in the first place, right? So we think there's a problem with stashing. And the problem is that it is an unmotivated concept. As we've seen, we tried to map this to any of the high-level purposes of version control. And it's very hard to do. And we believe the reason for this is that the motivating purpose for the inclusion of stash results from other decisions in Git's design, such as, for example, how branching works, and not from the intrinsic complexity of version control. And that maybe, if branching worked differently, then it wouldn't be needed at all. So for detach head, we have a coupling problem. Since the head can detach from a branch and point directly to a commit, the user can create a new line of development, right, that is not referenced by any branch and that is hard to switch back and from to. For untracking file, the problem is that assumed and changed and ignored violate the non-division criteria. The same purpose, that is to prevent the accidental commit of a file, motivates both the concept of an ignored file and assumed and changed file. So the user needs to learn another concept and a separate set of commands to do the same thing that the ignore mechanism provides. Now, this is actually not what assumed and changed was initially designed for. It was intended to be used as a performance optimization, right? But has since been appropriated by users as a way to ignore tracked files. So we have an analysis of Git. Gitless is our attempt to fix the misfits we identified by reworking Git's conceptual model and kind of try to experiment with different reworkings of Git's concept model and see what would be the impact of doing such changes. So it's a version control system built on top of Git, like another porcelain of Git. it presents a different concept model to the user. And I like to clarify that, as I said before, it is an experiment. That is, we don't claim Gitless occupies an ideal point in the concept design space. There are actually many different ways in which you can fix the misfits, but I'll show you what we did in Gitless. So let's talk about branching in Gitless. So in Gitless, a branch is a complete independent line of development. Each branch includes the working version of files. That is, it is as if there's one working directory per branch, and also maintains the information of any sync operations such as a merge and so in progress. So even during merges that you're resolving conflicts, the user is still working on the original branch and can switch to another branch and then go back to fixing conflicts later. We also removed the staging area, so stage contents cannot prevent switching branches, and there's a single and direct path in both directions between working and committed versions. And to account for common use cases of staging in Git, such as splitting a large change into multiple commits and so on, we have a flexible commit command that has flags for most of these common use cases. So we have like a -p flag, like git commit -p. Our concept of branch eliminates the need for stashing, so there's no stashing in Gitless, because essentially you can switch between the branches without any interference. And for detach head, so basically in Gitless, there is no possible way of getting in that detached head state. At any time, the user is always working on some branch, which is the current branch. And head is actually a per branch reference to the last commit of the branch. Regarding untracking files, in Gitless, committed files can be ignored or untracked. And actually, in Gitless, the only files classifications are tracked, untracked, ignored, and in conflict. And files can move freely between these classifications. OK. So we wanted to see what was the effect of these changes. Right? So we conducted a small user study. And each of the 11 participants we recruited did a session using Git and another one using Gitless. Note that while all of the participants have used Git before, they were encountering Gitless for the first time. So the tasks we asked them to perform are listed there on the right. All the tasks were in the context of a reasonable flow. And we measured a bunch of things. But I like to focus on the results comparing Git with Gitless. And if you want to learn about the other results, you can go read our paper. I have a link to it in the end of the presentation. OK, so at the end of the second session, once they were done doing a session using Git and the other one using Gitless, sometimes they started using Gitless and so on, we asked them to complete a questionnaire comparing Gitless with Git. And overall, participants enjoyed using Gitless and found it easier to learn and use. But when asked if they would continue using Gitless if they could, the results are somewhat split. So some, for example, show concern about its power, which is not surprising since Gitless is just a prototype, while Git has been in use for over 10 years, right? So there's a lot of functionality built in there. If you break it down by Git proficiency, you see that Git novices rated Gitless very favorably. And while novices really liked it, experts didn't find it worse than Git. The reactions are pretty neutral. They said they would not continue using Gitless if they could. But of course, they already know all of Git intricacies, so they have less of an incentive to switch. So of course, this doesn't mean Gitless is better than Git. The study focused only on misfits and only on these problems that we identified, and did so in a controlled environment. A full evaluation of a version control system would require testing it in the context of large projects with complex requirements and so on. Yet, at the very least, the results from our study provide some empirical evidence that our redesign efforts were fruitful, and that this approach of focusing on purposes and concepts might be a good way of making Git easier to learn and use. So I've shown you how we can use this theory of concept design to redesign Git so that it's easier to learn and use. But the same approach could be used to design new Git portlanes that look more like a different version control system rather than a new Git client. There are many Git clients, right? From those that have a graphical user interface to those with a command line interface, which includes your aliases and so on. But for the most part, these make largely cosmetic changes. They have the same concepts, for example, a branch being appointed to a commit, or having the concept of a stash and so on, but they present them differently. And I believe there's an opportunity to go deeper and develop new Git portlanes that are really more like a new version control system rather than a new UI to Git. I've talked about what we did with Gitless, but that's just one way of fixing the problems. Maybe you have a better idea of how to rework the concepts to fix the problems I've talked about. And I think there's also an opportunity to create version control systems built on top of Git that have a set of concepts that are specialized to a particular domain. For example, what would a version control system that is designed for writing research papers look like? What concepts would such a system have? Or what about if you want something that is specifically tailored to your company's needs? OK, so to conclude, our hypothesis is that what's wrong with Git is its concepts, and that to make Git easier to learn and use, we need to be willing to experiment and redesign its conceptual structure. Thank you. And if you'd like to try Gitless, you can download it from gitless.com, and you can get our paper by visiting that link over there. And that's it. Thank you very much.